Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is another MCQ. The question is in front of you. I request everyone, please pause the video, try by yourself. Whatever answer you get, please write in the comment box along with few words of explanation. I believe you have tried, so let's start. Now the question is, what is the major product of these reaction? So this is actually allyl bromide. Remember, this is the double bond and this position sp3 hybridized carbon attached to this. So this is allylic bromide or allyl bromide. It treated with metallic magnesium in anhydrous ether. By the way, when we look at this condition, you may consider, okay sir, magnesium anhydrous ether means, are you talking about Grignard reagent? Yes, but the problem is not that much simpler. Now the issue is that 0.5 equivalent Grignard reagent. So what will happen? That's the question. And from all four options, I guess you may think like that, okay, this is not Grignard reagent, this is not, maybe option D. Let's look at that. So for that purpose, let's look at the mechanism. Now if you look at here, this is Grignard, this is actually a Grignard reagent preparation. First let's understand the concept. When you react a means alkyl halide or aryl halide, both are possible. So if you treat them with metallic magnesium in anhydrous ether as a solvent, what happened? This magnesium releases 2 electron and this magnesium converted to 2 plus and this 2 electron. This 2 electron reduces this Rx and ultimately produce RMgX. Sometime we write that R is delta minus, this X is delta minus, magnesium delta plus, or sometime people write R minus, Mg2 plus, X minus. By the way, the first one is more accurate, I believe, because if you look at this carbon magnesium bond, it is actually generally, I repeat my statement, generally nearly 34% ionic character exists. So I shouldn't say it's a ionic compound, so that's why this is not good. But if you think in this way, you can explain the chemical properties also. But this is more accurate. So it's a polar covalent bond. But the story is here, this step. This is actually, student, not directly these 2 electrons are released. They release stepwise. Actually, Grignard reagent releases 1 by 1 electron, means it follows a single electron transfer mechanism. Now what happens for single electron in this allylic bromide? Now if you look at here, if you give a 1 electron to this CBr bond, what will happen? Actually it will produce a allyl radical and Br minus. What do I mean? So if you give 1 electron, this electron will go, obviously, where? It will go to sigma star. Now when sigma star it will go, the bond becomes weaker, because sigma star antibonding orbital should be vacant, bonding orbital, I mean sigma, should be filled, but since electron is accepted in the sigma star, it break down. And now this is a covalent bond. It's actually a shared pair, means this is made by sharing 2 electrons from the individual atoms. Now if you give 1 electron extra, so what will happen? This part will be converted to Br minus, octet filled. Now here, what about this? It is a radical 7 electron species. Now the interesting point is that, so why this radical will be produced, that will be decided by the stability of this radical. Yes, actually this radical has stability, so it will give 1 electron, it will open. So representation radical comes here. By the way, you may think, why I am giving half arrow? This arrow is called fish hook arrow. See, I guess many of you have seen this fish hook. So this looks is the fish hook looks. So we put food and catch fish here. Okay, since it's a half arrow, and half arrow is because of the movement of single electron. So in this way, allyl radical is produced. By the way, this allyl radical is resonance stabilized. What do I mean? The radical is distributed on these 3 atoms. Generally, I repeat, remember, these radicals are not a very stable species. They are metastable species. But because of this delocalization, its stability is increased to some extent. Okay, it is deficient, but deficiency is delocalized. So this carbon, or this carbon, none of them are that much electron deficient. That is the reason, okay, they are moderately stable. By the way, very often we say these radicals stable, very stable, less stable. See, radicals, they are not stable. They are 7 electron species, incomplete octet, they are reactive. So their stability is improvised to some extent, relatively. So this is now in the next phase. What can happen? These radical can combine. How? By the way, it with another more radical. So you may think like that. So these half electron, half arrow, in this way they form a bond. So what is the expected product? Both end there will be double bond. So this is one of my vinyl. Now you can expect what about the other side? Other side is this one. Now by using different kind of inks I have shown. Am I right? Answer is no, I am not right. There should not be any, so there should be 3. In this case, student, very often I have observed student make mistake. This is a C3, carbon 3 compound. This is a carbon 3. So it will be total carbon 6. So remember this part, very important. Okay, so this CC bond is actually formed by radical coupling. Okay, now a simple question, why this? Because generally for Grignard reagent we don't see this. Why this thing we are observing here? First of all, anhydrous ether. So anhydrous conditions, only one option, magnesium will release electron that will break this bond. Now how much equivalent of Grignard reagent magnesium I have given? 0.5. Now another question, someone can say that sir, you are showing this radical mechanism, rather than you can show this that okay, this is your Grignard reagent, half equivalent. I am saying 0.5 equivalent Grignard reagent react with 0.5 equivalent bromide. Okay, this is one option, plus it will react with this bromide. So via SN2 pathway, means as I told you some time before, it's like a carbon. Here you can see it's a carbon ion character. So these carbon ion can't it attack there SN2 fashion, and we know allyl halides are prone to SN1, SN2 both very reactive. Answer is no. Remember, Grignard reagent generally does not act as nucleophile for such kind of reaction. I mean SN1 or SN2, they don't participate. They act as nucleophile when you are talking about the nucleophilic addition with carbonyl compounds. Okay, that case, but not this case. So here this strategy, although it will take you to the right answer, but this is a wrong mechanism. Remember, Grignard reagent actually preparation reaction is involved with a single electron transfer mechanism. Okay, so what is the product here? So from this study, I guess we have understand this is the product. Now this, if this question appears in your exam less than 30 seconds, how can you solve? For that purpose, you need to understand, you need to read the question very carefully. Student, very often what you do during the exam excitement, okay, allyl bromide, magnesium, Grignard, so nothing given, so it is none of this. No, please take a little deep breath, read the question carefully. 0.5 equivalent, so it is nothing mentioned means it is 1 equivalent. 0.5 equivalent, okay, you should understand, okay, 0.5 equivalent Grignard reagent will be prepared. But in this context, I suggest you to remember this information, single electron transfer mechanism. So first it will produce radical, no other reagent is given, so radical coupling. Now if you look at this, if you look at other option, are they really logical if you think from radical point of view also? So one radical and another radical, they are combining. So these radical combine with these radical, will it combine with double bond? No. This allyl radical is there, 7 electrons, it will react with that. So how this is possible? In order to form this CC bond, you need to have a radical here, radical here. These radical, this is called vinylic radical, they are not in conjugation, they are not stable, so this product formation not possible. Even these also no, one side allylic, another side vinylic, no, that is not possible. Okay, this is actually possible. So I believe that this information you should remember, then it will help you. So this is the overall discussion. I believe this video may be useful. Thanks for watching. See you in my next video. Bye bye. And regarding any doubt about the logo of my channel, please read this part. Your doubt will be clear.